Hello everyone and welcome to another video. Today we're going to continue with arithmetics and we're going to try and implement division. So in the previous video we were implementing precedence using parentheses, and we also implemented multiplication. Let's copy the arithmol to div, and we're going to do something like this. Print I, what are we going to divide? Let's divide 10 divided by 2. If I remember correctly, we did implement the division token, but I don't think we're doing anything with it at the moment. So yeah, it's not really working. So in our front end, we will just add another one here, else if token div. And actually I just want to see if we are ending up here first, just to be sure. So we're going to do a printf division. Yeah, we're ending up here. Cool. So if you read, so there's this assembly operator called div, and if you read about it online, they will say that you should avoid using it because it has bad performance. But unfortunately, I'm not skilled enough on assembly at the moment to do it in another way. I know you can do it with bit shifting and stuff like that, but we're going to keep it simple right now, and we're going to work on optimization another time, you know. And actually, we're already using div when we're converting integers to strings. So that one will also be optimized in the future. But anyway, so we're going to get rid of the iml, and I think we're going to want to pop the second one into ECX, and then we're going to want to div ECX, because this will, I think this is going to do something like this. If I remember correctly, it's going to do, so div will do something like this. It will do EX divided by ECX, and it will put that inside of EX. So what do we have in EX at this point? So when we're popping EX, we're actually popping the divisor. So maybe we should actually do this the opposite way, the other way around. So, oh, sorry. I think we want to do this first, because we want the divisor in ECX. Might be wrong. Sometimes I'm wrong, and it's okay to be wrong sometimes. 0. So maybe that was wrong. Okay. Yeah, so it was, why is, oh, because I'm actually doing, all right, because they are being visited in reverse, I guess, so, well, that's confusing. So, okay, div seems to be working, because we are expecting 5 here, right? What if I do 16 divided by 4? Cool. What if I do divided by 4 divided by 2 like that? 8, which is correct. Okay, seems to be working. What if I do divided by I don't know. Let's do 32 divided by 4 times 2. Yeah, it's correct. So I think we can conclude that division works. Let's also try and put this in one of these in a variable. No. Oh. And that works too. Cool. I wonder what would happen if I did like x plus 1 here. Yeah, it breaks. So what I think is happening here is that it's actually adding x to the pointer here in this case. Let's simplify that a little bit. Let's do int x int is equal to 1. So we would expect the result of 2 here, right? So I think it's actually shifting that pointer. Maybe we should add a bit of comments to our output so that we can debug things easier. So let's add comments here too. No, that was not. That was subtraction. So we're popping into EX. think we need some more comments here. So push 0 EBP. So this means that, okay, the contents of that variable, wait, push 0 EBP. That seems very wrong. Or is it? Let's add a comment here as well, I suppose. It's too difficult to get the value. We're just gonna skip that for now, but now we know that we're assigning something here. So here is where we're assigning the x. Here's where we're visiting that x, and we're pushing it to the stack. But it seems wrong to me because it's not going to be at 0 EBP, is it? It's going to be at minus 16 ESP. Or even in this case, 0 ESP. So why is it not using -16 ESP here? Could it be that it is because it's inside of a call and so if we look at the parser and we look at how it's parsing the call, it's going to parse the list. And it's not going to, it shouldn't go into here. So I don't think this is what's going on. What else could go wrong here? We're not creating a new stack frame there either. So I feel like here is where it's going wrong, possibly. No, that's only happening when we're doing the we shouldn't go into here. Yeah, so that's not happening. Okay, so it's still, that seems to be all good actually. Push 0 EBP. If I change that to -16. Did that make it correct? Yeah, it's supposed to be 2. So why is this becoming 0? Stack index. first of all, we're adding 2 to that stack index. So I'm never encountering this. So that's a problem. Oh, because we're actually going through a bin up here, and we need to visit those, I suppose. Yeah, that's the problem. So now we're getting minus 16 EBP. Cool. So it works now. Perfect. So now we can do that. And let's do 10 divided by 2. 5. Cool, so that works. So division has been implemented. That's perfect. And now we're getting to a stage where we got a lot of implementation. We got a lot of different implementation of different things, or not different implementations, but we have a lot of features in our language now. So I think in the next video I'm going to work on unit tests actually, so that I can avoid breaking things. But first I want to update the readme file here. I think we should remove this, and we're gonna have implement addition. And addition, division, multiplication, addition. Oh, I forgot division. And I'm going to remove this implement arithmetic. to do because it's a bit ambiguous. By the way, this line here is pretty interesting because I've actually tried this. and it actually works. So maybe I can show you this in another video, but since I'm using the ABS something calling convention, or the C calling convention, I'm currently, like even now, able to call functions from other compilation objects. So like I can write a function in C and I can call it from my language. It actually works. I've tried it. So maybe I'll show you that in a separate video. But it's pretty simple. So as you know, right now we don't have our own assembler or our own linker, but our plan is to obviously write our own in the future. But right now we're using the GNU assembler, and basically you can pass in an argument to bundle it with some object file, like a shared object file, and you'll be able to access all of the symbols inside of that file. So yeah, we'll get more into that in another video, but I have an idea for how I want to dynamically load libraries like that. So for example, let's just create another file here called I don't know, shared, I don't know, and I want to implement a syntax for that. So basically, let's say I want to use functions from the standard libc library. In C, you would do like include stdio.h, and you'll be able to and you know, it will automatically link libc to your elf file. And I'm thinking I want to implement a sort of syntax for using shared objects, or to tell the linker that we want to link another elf file or another shared object into our compilation unit. So I was thinking about maybe implementing something like this: use libc, and it will use that. The linker will automatically link it into the elf file, because it will parse these use statements. And maybe I could also do like use, I don't know, lib. What other libs are there? You know, maybe I want to use lib pthread or something. I would do use lib pthread. We might even be able to just discard these lib things like this. So you would do something like that. I don't know. I haven't really decided yet. This is a lot more cleaner, and it will automatically look for the library you're trying to link. So basically, after I have done use libc, for example, I can now access printf, which comes from the standard the standard C library. So, and you know, I have already tried this. I'm going to show you this in a separate video because I want it to be a separate topic, but just to let you know that it actually already works. Well, this syntax here doesn't work. I've just been experimenting with that idea of doing something like that. But I think in the next video we'll start working on unit tests, actually, because it's important so that I can avoid breaking things. But anyway, thank you for watching.